This video is for section 8-3 about circles. In chapter 8, we've been looking at some geometry concepts that are connected to algebra. We discussed how to find the distance between points and also how to find the midpoint between 2 points. We're now going to discuss circles, and this is related to the idea about distance because a circle is defined in terms of distances. Here is the definition of a circle. It is the set of all points that are equal distant from a given point called the center. The distance between the center and any point on the circle is the radius. Here's a drawing of a circle. On the actual circle, there are many dots. There's a dot here, there's a dot here, 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 and so on. An infinite number of dots around that circle. Every one of those dots is the same distance from this point, which is the center. So we can measure the distance between any point on the circle and the center using the distance formula from the previous lesson. That leads us to the equation for a circle. And here it is. This is the general form for the equation of any circle. X minus h squared plus y minus k squared equals r squared. H will be an actual number, k will be an actual number, and r will be an actual number. Just like with parabolas in the last chapter, the letter h and k go together to tell us the center. For parabolas, h and k got us the vertex. For a circle, h and k are numbers that will give us the center. The letter r means radius. It tells us the distance from the center out to the edge of the circle. Look how much this basic formula looks like the distance formula from the previous lesson. If we were to take the square root of r squared to get distance r alone, on this side we would have the square root of this stuff. This is a lot like the other day. It's just instead of h, we had what? x1 there. Instead of k, we had y1. Same basic pattern, right? Let's try an example. We're going to find the equation of a circle that has a center at the origin and radius 2. The origin is 0, 0. Based upon our general formula that works for all circles, the x-coordinate of the center is called h, the y-coordinate of the center is called k. The radius is the number 2. We're going to call that r. Here is the general formula for all circles. X minus h squared plus y minus k squared is equal to r squared. Let's make our substitution for the center. We have x minus 0 squared plus y minus 0 squared equals, what do we fill in for r? 2 squared. This simplifies to simply x squared plus y squared equals 4. Here is the equation of a circle. The center's right at the origin and the radius is 2. Do you remember how easy it is to graph a parabola when the equation is in vertex form? It was a little bit easier to do that than when we had the equation in standard form. When it wasn't in that form, we were able to use completing the square to transform it. And we can do that with equations of circles as well. So here we have an equation. It's got x squared in it, it's got y squared, it's got some other terms. This is a very complicated equation. 4 terms on the left side. Let's use completing the square to make this look like the general form for a circle. First of all, separate the part that has to do with x from the part that has to do with y. Let's rewrite those and leave some space here. And leave some space right here. This is so we can do our completing the square process by figuring out what constant term is needed to make perfect square trinomials. We've done this quite a bit this year. Take half of this number, so half of negative 2 is negative 1, and square it. That makes positive 1. Add that in the blank spot, and on the other side of the equation to compensate. Now let's figure out this number here. Take half of the 4, which is 2, and then square it. That makes positive 4. Add it in the blank spot and on this side to compensate. Now let's rewrite this trinomial in its factored form. It's x minus 1 squared. Then let's rewrite this trinomial in its factored form. What's it going to be? It's y plus 2 squared. Then on the right side, add these numbers up. It turns out to be 9. This fits our general form for a circle. Remember what it was? It was x minus h squared plus y minus k squared, and then it was equals r squared. We don't have an equals, we have a less than symbol. That just means we're going to have some shading in our picture. Now let's figure out the values of h, k, and r for our equation. Look what's in the same spot as the h, after the minus sign. It's the 1, so h is 1. Now the letter k is a number that comes after a minus. In our equation, we don't have a minus. Y plus 2 is really the same thing as y minus negative 2. So the letter k is negative 2. Now, over here on the right side, in this spot we have a 9, and that's equal to r squared. So what's the answer for r? If r squared is 9, what's r? R is 3. We have all the numbers we need to make a picture of the circle. We use the h and the k to get the center of the circle. So let's find 1 common negative 2. Over 1 and down to negative 2. There's the center. Then the radius is 3. Well, what does that mean? It means from the center, you go out 3 units in every direction. Well, going horizontally is very straightforward. Here's a dot 3 units to the right of the center. Here's a dot 3 units to the left of the center. Going up and down is also very straightforward. Here's a dot 3 units below the center, and here's a dot 3 units above the center. Going diagonally is not as easy. If you have a ruler, you can measure how far it is from the center across to this mark, and then you can lay your ruler on more diagonally and measure that same amount. Another thing you can do is just take a little scrap of paper and use it like it's a ruler. Like, put one edge of the paper right there at the center, and then have the paper just kind of go across and put a mark with your pencil on the paper. Then hold this corner right at the center and kind of spin the paper around so that you're able to get other dots as you're moving that paper around to see where the circle is. When you get all done, you want to have a very accurate circle that doesn't look all football or egg-shaped, all squashed. Okay, now, do we want to have a solid boundary line on our circle or a dashed line? Do you remember how to tell? Does our arrow have the or equals to? And it does. So we have actually a solid circle boundary. So I'm going to draw in as carefully as I can a solid line going around in a circle. That's about the best I can do freehand without actually measuring with a ruler or with that piece of paper technique that I mentioned. Now, where do you think the shading is when it's a is less than? Do we shade inside or outside of the circle? Where are all the numbers that would have a radius less than 3 units? That would be inside. So color in the entire inside of the circle. We're coloring over an infinite number of dots. Every one of the dots is less than or equal to 3 units from the center. Let's summarize this lesson. We discussed circles, and we saw the general formula for a circle, which is right here on the screen. You're going to use this just like you use the general formula for a linear equation or the general formula for a parabola. The h, the k, and the r will be actual numbers. So one skill is if you're given numbers for h, k, and r, substitute them in there to make an equation. The opposite skill is if you're given an equation, can you make the graph? If you ever have an equation that's not in the general form, you can rewrite it using this completing the square technique that we saw in this example.